Hi guys, welcome to YMaths Land. I'm Yan Yan. Today I'm going to talk about more calculation of the derivative. I'm going to show you the implicit differentiation. For the first relationship, x cubed take away 2xy equals 5. We do both sign derivative. The change in x cubed take away 2xy with respect to x equals the change in 5 with respect to x. We know the derivative of x cubed equals 3x squared. We use product rule. The derivative of xy equals the derivative of x equals 1 times y plus x times the derivative of y equals 1 times the change in y with respect to x. Here, it will equal y plus x times dy over dx equals 0. So we simplify it equals. Have a look the second one. First step, we do both sign the derivative. The change in x cubed is 3y plus 4x squared y cubed with respect to x equals the change in 27e to the negative 2x power with respect to x. 3x squared times e to the 3y point plus x cubed times the change in e3y with respect to x. It equals e to the 3y power. We use the chain rule. We have 3 here, so with the chain rule, we times 3. And we multiply. Keep going. For we use product rule, it equals 2 times x times y cubed plus x squared times, how to do the change in y cubed with respect to x. The equals, we put 3 in front of y. 3 minus 1 equals 2 times the change in y with respect to x. It equals 27 times negative 2 times e to the negative 2x power. That's it. Next step, we just simplify. First step, we do derivative to both sides. We use the product rule. The derivative of e to y equals e to y times 2 times the change in y with respect to x times ln x squared plus e to the 2y power times the derivative of ln x squared equals 1 over x squared times 2x. So first, the change in e to y times ln x squared equals 2 times e to the 2y power times ln x squared times the change in y with respect to x plus e to the 2y power times 2 over x. So next, we use product rule as well. The change in y cubed x with respect to x equals the change in y cubed equals 3 times y squared times with the change in y with respect to x times x plus y cubed times derivative of x equals 1. The change in y cubed x with respect to x equals 3y squared times x times the change in y with respect to x plus y cubed. So last term, the change in log xy with respect to x equals, we use the chain rule, 1 over x y times the change in x times y with respect to x. This is a product rule. It equals the derivative of x equals 1. 1 times y plus x times the change in y with respect to x. So it equals 1 over x plus 1 over y times the change in y with respect to x. For the right side, it equals 0. So the change in y with respect to x equals. So we can simplify for up times x times y, for the bottom times x times y. So we can simplify. So we just both times x times y. Let me show you the derivative of the trigonometric function. First, you should know the derivative of this function. For the derivative of tan x, it equals secant x squared. For the derivative of cotangent x, it equals negative cosecant x squared. For the derivative of secant x, it equals secant x times tangent x. For the derivative of cosecant x, it equals negative cosecant x times cotangent x. So for the first one, the change in y with respect to x, we use the chain rule. It equals 1 over cosecant x times we know the derivative of cosecant x equals negative cosecant x times cotangent x. So we simplify, it equals negative cotangent x. Second one, we should know the derivative of fx divided gx. It equals derivative of fx times gx. Take away fx times the derivative of gx divided gx squared. Then we should know the derivative of secant x. It equals secant x times tangent x. We also know the square root of secant x equals secant x to the half power. So the derivative of square root of secant x equals half times secant x to the negative half power times the derivative of secant x. So we simplify, it equals. So the change in y with respect to x equals derivative to x equals 1 times square root of secant x. Take away the derivative of square root of secant x times x. Divide secant x. Then we substitute equals. We can both divide square root of secant x. equals 1, take away half tan x tan tangent x, divide square root of secant x. We can keep going because we know the tangent x equals sin x over cos x. The secant x equals 1 over cos x. Then we can both tie square root of cos x. So it equals square root of cos x, take away x times sin x over 2 times square root of cos x. That's it. The derivative of cotangent 2x equals, we use the chain rule, it equals negative cosecant 2x squared times the derivative of 2x. So it equals negative 2 times cosecant 2x squared. The derivative of ex equals ex. Now we do the change in y with respect to x. We use the product rule that equals ex times cotangent 2x plus ex times derivative cotangent 2x. Then we simplify. I'm going to show you the derivative of the inverse trigonometry function. We should know the derivative of arc sin x equals 1 over square root 1 take away x squared. X belongs to negative 1 to 1. The derivative of arc cos x equals negative 1 over square root of 1 minus x squared. X belongs to negative 1 to 1. The derivative of arc tan x equals 1 over 1 plus x squared. X belongs to real number. So I'd like to show you the first one. The change in y with respect to x equals 1 over 1 plus x squared, that is x over a squared. Times, we use the chain rule, the derivative of x over a equals. Then we simplify. For the last one, we use the product rule. The change in y with respect to x equals the derivative of x times arc sin x plus x times the derivative of arc sin x. Derivative of x equals 1. The derivative of arc sin x equals 1 over square root of 1 minus x squared. I hope you like my video. Thank you. Bye.